how cost-effective a construction can be and get a construction awesome. Absurd to draw. So, with the experience and with the collection of data, how can we optimize designs rather than blindly following the standards or the guidelines? So I'm not saying that the standards or guidelines should be neglected, but data is showing a totally different picture. What is a standard and what is actually happening? So let us see from whatever data collection internationally, as well as we have some data which is collected by ourselves. So two things. What is lack of data is one which is stopping us from optimizing the engineering design, and then post-occupancy evaluations. Post-occupancy, what has happened with the occupancy, what really is the measured value. Just first is the electrical systems. The electrical systems, I have taken the plug load as an example. Plug load as an example because there was a study which was published by American Society of Healthcare Engineering some time back. This is a hospital in New Zealand. They have done a study for about 6 months, and with what was designed and what was measured, so these figures were really surprising. So I thought I will share the data so that we can also do some research, some data collection from Indian perspective and optimize the design, discuss, make the authorities understand, okay, fine, why are we spending a lot of money or taking a bigger infrastructure for things which are not going to be used. So it's always like, when we design, we look at the worst case scenario and say that, okay, we have to be safe. So safety is, you have to be safe, but how much money are you spending for that safety? This is just the example. The small line is the actual data, and the big line is the design. So you can see at least it is 10 times more plug load in every surgical ICU or neurosurgery ICU, post-acute care, everything, including patient rooms. Every data was taken for 6 months. And this was done by some from the American Institute of Architects and a lead and a guide. So this is not done properly in this part of the world. This is not done properly in this part of the world. The moment we start doing this, we will be, able to optimize the design. Because you see, it is 2 watts per square feet to 20 watts per square feet. The actual design is 20 watts per square feet, and my consumption always take an emergency, critical, or conditions. It's just 2 watts. So you make it 5 watts. You're again saving a lot of money. So this has to happen. This is not happening because we are not collecting data, and you do not have data. And this data consolidation has to happen. And some authority has to come forward and say, okay, fine, I have this data. Hospitals has to help. The administrators has to help and say that, okay, this is what is happening. When I'm doing next time, you don't know. I know for the past 5 years, this is what has happened. In 5 years, this has never crossed 2. You do it at 5. Don't do 20. So that is where the optimization. So data collection is very important in MEP design. Data collection is very important. So this is the data. This was published in 2012, if I'm right. This is published in 2000. We do not have any data like this available. Similarly, this is done by us. So for a similar hospital, heating capacity of a hospital A, 176, hospital B, 160, hospital C, 108, hospital D, 84. 84 is what we have done. And I have 1 year data. Full occupancy, 80%, you can say. 80% occupancy, I have 1 year data. Perfect. Fully. What is everyday consumption of water? Even of air conditioning. This is what my design basis. I generally don't see. We have done this, and the past 3 years, one hospital is running at 0.73 kilowatt per ton. We have done it, the estimation at 0.75 kilowatt per ton, and it is running at 0.73 kilowatt per ton. Documented. Documented. I have the data. So, that courage has to come from the consultants. We as a firm has taken this up, and we are confident, and we are collecting data. We are in a position to publish the data also. But there has to be a forum. There has to be a forum where this can be published, this can be discussed, so that optimization happens. This is going to have a huge impact on running. Any older hospitals, it's somewhere around 0.9 to 1 kilowatt per ton. 0.73 is good. 0.7 is excellent. 0.7 is excellent. So let us have that confidence built in the designers. Let the administrators, the CEOs, the owners ask, okay, what is my IKW per TR when you're designing my HVAC? You please come forward, you ask. Then the consultants are pushed to do that. Internationally, it is done. It is only this part of the world it is not done. I'm not saying that no, there are a lot of people who might be doing it, but we do it. But I see a lot of people who are not doing it. Let us have all. Make everybody do this. Make everybody do this. We save a lot of money. It is a question of saving a lot of money, which will help you increasing your EBITDA. What will happen is, there are people who come evaluate an older hospital and say that I will do some energy efficiency, I'll change my chiller and all. What do? Older hospitals, they come, they change the chiller, night, they change the set point. Increase the chiller set points from 7 degree to 12 or 15. What is that loss? Humidity will go up. Older hospitals does not have a mechanism to have the humidity checked. You will only look at what is the ultimate benefit you are getting. When you do newer hospitals, let us have, somebody coming 0.9, I'll make it 0.7, 0.7 or 0.8. Let that opportunity be not there. You design with 0.75, 0.8 or whatever committed. So this kind of, one, the data collection. Second, the administrators, the owners, pushing the designers for these kind of targets. So I feel that lack of data collection, sharing of data collection on a common forum, all that is required. And for that, the CEOs, the administrators, the owners, all has to understand and cooperate. Similarly, for a medical gas pipeline system, as per STM, 12,000 LPM for a 9 lakh square feet building. When we measured, it was 5,000 LPM. Measured, we did an audit for a hospital. When I did an audit for a hospital, as per STM is one of the standard to be followed, international standard. So as per STM, it is 12,000 LPM. We have a lot of equipment which is running there. With all the thing done, for the past 2 years, it has never crossed 5,000 LPM. It has never crossed 5,000 LPM. What we did is we proposed a 6,000 LPM, one step little more. And space, if you have an eventuality. Space to put in, you buy and put later on, if there's an eventuality. So there will be a lot of money. You save a lot of money. So this data collection, this is again, we have done this data collection. We have done this data collection. We have done these calculations as well. So my main point of discussion was that, so let us all align, help ourselves, help each other to reach there. Internationally, benchmarking is there. We do not have benchmarking. Let us have this benchmarking happen, and let somebody take an initiative. We are too small to take that initiative. So it's a forum where I can speak and say that, let us all come together and bring that initiative and have the benchmarking done so that we save a lot of money on engineering infrastructure. Thank you. International benchmarking is there, but what will happen is the temperature conditions are different. The way they operate is different. You do not have that kind of crowd in an international hospital like how we have it in a hospital here. So it's all pattern-wise different. Pattern-wise different. Benchmarking, when we benchmark, we will be much superior to some international hospitals. And as my previous speakers told, isolation room exhaust has to be done through a HEPA filter only. They do it only with a HEPA filter, and air changes are as per book. So I don't think we can do all that as per book. There will be some compromises here and there, depending upon the situation. So benchmarking has to happen for this nation, for this part of the world. Dry areas, humid areas, all that has to be different. So data connection is very important. Post occupancy, designers has a responsibility to connect data. Post occupancy, designers has a responsibility to collect data post occupancy. As long as they don't do it, we again and again do the same mistake. And we look at some international standards which might not be relevant for us, We end up in overspending.
But the illusion halls, and we have to make any changes of that. It actually pigments and we should get it, but it's definitely what to then apply this. Well, I'm accepting concern. We'd be happy to pay for the clips. Should that with be loaded. Fellowship on cancer days Joe. Well, but this that is the bad in our company clean the tea thing. Odd we people get that is.
How does guideline come? With connection of data, with some basis. Let us start collecting data and look at the guideline. Where are we? How can we change? So, point is, you have to collect data and then standardize the data, go back to the authorities, say that, okay, fine, this is what is happening, this is what is right, and this is what to be implemented.
Thank you very much. I'll take the question.
Thank you, sir.